Hello everyone, I hope you're doing well. In this MTH 141 video, we're taking a look at question 1.2.2 from the textbook A First Course in Linear Algebra by Kuttler. You can find my notes for this course on my website, tutor.ca, where you can also find information about my private tutoring services. Okay, so let's take a look at this question, 1.2.2. Find the point of intersection of the two lines, 3x plus y equals 3 and x plus 2y equals 1. So this is a system of equations, 3x plus y equals 3 and x plus 2y equals 1. So let's write it out as a system. So essentially how I write things as a system usually is a little bracket like that, and 3x plus y equals 3, x plus 2y equals 1. The bracket doesn't actually mean, well, the bracket just means that these should be looked at together as a system, right? It doesn't really add to the math at all. It's just sort of, it's the same thing as if you just said, like, this is a system. Right? This is a system, right? Although that's, system. Although that's not the best notation. You have to write the whole sentence every time. So I write this to sort of mean that that's a system like that. Okay, so we want to find the point of intersection of these two lines of this system. So there's the method that we have to solve this, which is called elimination method. Elimination method. Right? And so here, elimination method lets us use the elementary operations on the system, which notably don't change the solution set to the system. It lets us change the equations how they're written in a way that, again, very importantly, does not change the solution set to the whole system. So if there's a point that is a unique solution to these two systems, so these two equations, I mean, which means that if I sub that point into equation 1, it's true, and I sub it into equation 2, it's true. Then by using elementary operations, the solution to the system that I get after I use elementary operations is the same as the solution to this system. So let's show that in action a little bit here. I want to morph this system in a way that gets it so that the final equation is just one variable, one unknown. So I can just solve for the variable. To do that, I need to remove one of the variables here. I need to remove either an x or a y, because then once I do that, it'll be one equation, one unknown. So usually you remove the x. It's probably the best place to start here. Remove the x, unless there's some specific reason to remove the y or something like that, right? But usually remove the x. First step in doing this, probably best to do, is to to make the coefficient, or all the coefficients, in front of the variable you want to remove to be equal to 1. There. So I want to remove x. Are all the coefficients of x 1? It's 1 here, but it's 3 here. To do that, to turn this 3 into a 1, I'm going to use the second row operation, or second elementary operation, which is multiply any equation by a non-zero number. So I'm going to multiply the first equation by a third, which would turn this into 1. 3 times a third is 1. So to do that, how I would write that is I'd say row 1 times a third. Row 1 times a third. Okay, and what's our new system? Well, it's going to look like this. So 1/3 times row 1 is going to be, well, 1/3 times 3 is 1. So x plus 1/3 times 1 is a third equals 3 times a third is 1. So there we go. We changed this equation by just multiplying both sides by a third. Row 2 doesn't change. 2y equals x plus 2y equals 1. Okay, so from here, now we can do another row operation. Okay, and that's a type 3 row operation, which is replace any equation with itself added to a multiple of another equation. So I'm going to take row 2, and I'm going to turn it into itself added to a multiple of another equation. In other words, row 2 is becoming row 2 plus -1 times row 1. The reason I'm doing this is because look what's going to happen. For each coefficient, for each variable, I should say, for each variable here, do this operation. So x minus x is going to be 0x, right? So our first equation here, well, actually, our first equation is going to stay the same. X plus 1/3 y equals 1. Our second equation, which is what's being replaced here, it's being replaced with x minus x, which is 0x, 2y minus 1/3 y, right, which is going to be 1 2/3 y, right? 1 2/3, yeah, which is going to be 5/3 y. So plus 5/3 y equals 1 minus 1, which is 0. Well, 0x is nothing. That doesn't, 0 times anything is 0, so that's just always 0. And we have 5/3 y equals 0, which tells us, which implies, sort of what this arrow means, implies that y equals 0. Right? What number do you multiply by 5/3 to get 0? Only 0. So we learn now that y equals 0. The solution to our system has a y value of 0. So let's go back up to this equation and try to solve for x, right? This is called back substitution that I'm doing now. Back substitution. Which is almost always done with these systems of equations, especially before you get to Gaussian elimination, which is our next section after this. So I'm going to take this equation and I'm going to substitute in y equals 0, which will tell us that x plus 1/3 times 0 equals 1, which implies that x equals 1. So we have our two components of our solution here now. X equals 1 and y equals 0. So the solution to our system, xy, equals 1, 0. And there you go. There's our solution to the system. So we did this in essentially 3 steps. Well, we wrote out the system to begin with. I decided that I wanted to make the coefficients in front of the variable that I want to remove equal to 1. That's going to really help here in elimination method. So make it equal to 1. I want to remove x, so I'm going to make all the coefficients in front of x equal to 1. I did that using a type 2 row operation here. Type 2 row operation. Then, to actually remove that variable, I did a type 3 row operation, which is right there, which is I'm going to say row 2 is going to become itself added to a multiple of another row. Row 2 plus -1 times row 1. What that does in this particular case is x minus x is 0x, 2y minus 1/3 y is 5/3 y, and 1 minus 1 is 0. That becomes what row 2 is. That's what's written here, right? Row 2 becomes row 2 plus da-da-da-da-da. And now that second equation, the reason we did that is because it's one equation, one unknown. We could just solve for y, which ended up being 0. Back substitute that into the first equation. Okay, plugging in y equals 0, and we just get x plus 1/3 times 0 equals 1, which implies that x equals 1. So our final solution to the question is xy equals 1, 0. Okay, that's everything for this question. I hope it was helpful. Thank you so much for watching, and have a nice day.